in math on something called regions of sets. So if you would title your 2-column notes as regions of sets. And you have already learned to use numbers to name one or more whole objects or sets. So today we will learn to name parts of the whole object or set. So our I can statement for today, and what we should be able to say by the end of the lesson is, I can name parts of a whole object or set. Push pause. Okay, today when we talk about fractions, notes, we are using a fraction is a symbol used to name. Today we're going to talk about two things. One, a part of a whole, or two, a part of a set. When we write a fraction has a numerator, n equals the numerator, and it's over d, which is the denominator. The numerator is part of the set. And then the denominator is all of the set. Or how many equal parts is this divided into? Push pause to write your name. Let's take a look at the first type of fraction, and that is part of a whole. I'm going to draw a rectangle on the other side. I'm going to draw 1, 2, 3, 4 lines in there. And I am going to shade parts. So I want to know what is the fraction of shaded parts? And I could also ask the fraction of unshaded parts. Well, first we have to see if we're going to answer the fraction of shaded parts, you count the shaded parts. And here we have 1, 2, 3 shaded parts over all of the set. And if we have 1, 2, 3, 4, 5 total parts, then our fraction would be 3/5 shaded. If I wanted to know the fraction of unshaded parts, then I would count first how many unshaded parts I have, and that would be 1, 2. That would go in my numerator, and my total parts are still the same. 1, 2, 3, 4, 5. So my fraction of unshaded would be 2/5. Push pause. Let's look at an example of fractions that are part of a set. 2-column notes. Our second example is part of a set. So over on the right hand side of my 2 column notes, I'm going to draw 2 triangles, 2 circles, 1 triangle, and 2 squares. And these are a set of shapes. So that's what this part of a set. These are a set. Our set is a set of shapes. And then I could ask what fraction are triangles, because I have triangles as a shape. I could ask what fraction are circles, because I see circles there. And I could also have what fraction are squares. So again, if I count up the triangles, I have 1, 2, 3 triangles. So that's how many parts. And I have 1, 2, 3, 4, 5, 6, 7 total shapes. So my fraction would be 3/7 are triangles. If I wanted to find my fraction for circles, I count how many circles there are. That's 1, 2 circles, so that goes in my numerator. And I still have 1, 2, 3, 4, 5, 6, 7 circles, or 7 total shapes, so that is 2/7 circles. The fraction of squares, I count my squares. That's 1, 2 squares, so 2 again goes in the numerator. And I still have 1, 2, 3, 4, 5, 6, 7 shapes. So the fraction of squares is the same as circles, as 2/7 are squares. Now, I could ask what fraction are, let's say, pentagons. And when I look at my shapes there, I don't see any pentagons. So the answer to that would be 0/7 are pentagons, which is the same thing as 0. Push pause. Let's do another example. If I have 3 circles, and I am going to shade 2 of those circles, and I want to know what is the fraction of shaded circles. And these are fractions of a set, because we have a set of circles over here. Well, I count how many are shaded. That's 1, 2. I count the total amount of circles. That would be 1, 2, 3. So my fraction of shaded circles is 2/3 shaded circles. Push pause. Let's do another example. What fraction of the squares contain a shaded circle? Part B of that question is what fraction of the circles are shaded? Push pause. Well, I'm going to draw here, I think. That's Not good. Let's try that again. Okay, I have 4 squares there, and I have 1 circle here, 1 circle here, and 1, 2 here, and 1, 2 here. I'm going to shade this circle, and that circle. Well, let's count how many squares have shaded circles in there. So we have a total of 1, 2, 3, 4 squares. That would go in my denominator. And how many squares have shaded circles in them? Well, I count 1, 2, 3. So 3/4 of the squares have shaded circles. The second part, or the second question is, this is part A, what fraction of the circles are shaded? Well, I would need to count those. So I see here I have 1, 2, 3 circles shaded. But now I'm counting how many total circles there are. So if I count those, I see there's 1, 2, 3, 4, 5, 6. So 3/6 of the circles are shaded. Push pause. Okay, for class, if you would do these 2 examples, bring them in worked. I would like for you to draw your choice with the fraction 4/5 of a region shaded. And then the second one, I would like for you to do 2/9 of a set shaded. Okay, give that a try and we'll see you tomorrow.